Example 2, we want to sketch another rational function. Did the last one tell us the domain? Oh, we forgot the domain and range. We'll quickly go back and do the domain and range. Okay, and we can see now on this video that we were supposed to do question number 3, which is obvious by that beautiful looking 3. Domain. Domain are your x values. Okay? You could do everything to the left of 1 and everything to the right of 1, but it would be accepted to say x can't equal 1, but x is everything else. You can read in the other order. You can write x can be everything, comma, x can't equal 1. That would be fine as well. Okay, same thing with your range. Your range, y can't equal 3, but y could be everything else. Perfect. Okay, example number 2. We start by factoring. Negative 2x squared over the bottom is a difference of squares. And so our non-permissible values, x can't equal negative 5, and x can't equal 5. Step 1, are those going to be wholes or vertical asymptotes? While we check, do any of our factors cancel out? No, so they'll both be vertical asymptotes at x equals negative 5 and x equals 5. I'll just write the numbers there so we can keep talking about the steps that we've planned. Step 1 was figuring out asymptotes, vertical asymptotes or wholes. Step 2, look if it has horizontal asymptotes or oblique asymptotes. In this situation, what happens when the degrees are the same? It's going to be a horizontal asymptote. And the horizontal asymptote's going to be where? At y equals negative 2. Again, if you look at the highest degree is the x squared and they're the same. How many x squareds are there in our numerator? Negative 2. How many x squareds are there in our denominator? 1. Ignore everything else. Okay? Because when x gets really, really big, that minus 25 is not going to be much of an issue. And that simplifies just to be y equals negative 2. Step 3, let's find our y-intercepts and x-intercepts. Y-intercept is the easiest. You just plug in 0 for x, and we will get 0 over negative 25, which is 0. Right? 0 over negative 25. You have 0 cupcakes and you want to share them with negative 25 of your friends. How many does each person get? Okay, not a good real life example. But the answer is 0. And your x-intercepts. Well, your x-intercept, if you plug in 0 for y, the only time you're going to get a fraction equal to 0 is if your numerator is equal to 0. When is negative 2x squared equal to 0? When x is 0. Which kind of makes sense. When you have a y-intercept of 0, it makes sense that you would also have an x-intercept at 0. Okay, but there was the possibility that there might be more x-intercepts. At this case, we only have the 1. So when we go to start graphing, okay, we put in our asymptotes. So we have non-permissible values, vertical asymptotes at negative 5 and positive 5. And we have our horizontal asymptote at negative 2. Label each of our asymptotes. Y equals negative 2, x equals negative 5, x equals positive 5. And right now we know one point. 0, 0. So what do? We need to find in part 3 some other points. Our vertical asymptotes separate our graphs into different sections. So we're going to need to find something to the left of -5, -6. If I plug in -6 back into my factored equation, -6 squared is 36 times a -2, -72. Here I would get -6 plus 5 would be -1. And here I would get -6 minus 5, -11. This becomes -72 over 11. Can you see that that number would be somewhere between -6 and -7? So we're just going to estimate where that value would be. 3, 4, 5, 6, 7. -6, -72 over 11. That point is there. Once I have that point in that section with the asymptotes that I have, I can finish drawing this section. We have nothing in the section to the far right. So we need to choose something bigger than x equals 5. So we'll plug in 6. I'll go back and erase our number from before. Now if I plug in +6, can you see that this will still be -72? But 6 plus 5, I would get +11 here, and 6 minus 5, +1 there. Well, that still is -72 over 11. So I go over to 6, 6 comma -72 over 11. And we have enough in this section to graph that. Now in the middle section we have a point. We have 0, 0. But we don't know, does it go up towards both of those asymptotes? Does one go up and one go down? Is it possible to go through a horizontal asymptote in the middle of your graph? Yes. So we don't have enough information here yet. But if we choose a value close to our asymptote, we might get an idea of what's going on. So for example, if I figure out what's happening at +4. Again, I just find, whenever you're in doubt, find more points. Plug in more values, find out what's happening with the graph. If I plug in +4, can you see that 4 squared is 16 times 2? In my numerator, I'll get -32. 4 plus 5 will be 9. 4 minus 5 will be -1. I will get -32 over 9, which is +32 over 9. That will be 3 point something. It's 27 over 9 is 3. So it's going to be at 3 point something. 1, 2, 3, 4. I have the point 4, 32 over 9. And that's enough information that tells me it has to be going up towards that asymptote. -4 + We'll plug in -4 as well. Check out our values. Well, we'll still get -32 on the top. -4 plus 1, 5 will be 1. -4 minus 5 will be -9. Surprise, surprise, we get 32 over 9 again. Has anybody analyzed the equation and figured out why this is happening? Why did I get the same values whenever I plugged a positive and a negative number in? It happened with -6 and +6. It happened with -4 and +4. Is it just coincidence? Or is there something in the equation? Yes, Taryn? The x's are squared. If we go back to the simplified, the equation before we factored it, we have x squared on the top and x squared on the bottom, no other x's. What happens when you square a positive number and square a negative number? They end up being the same thing. So it should be symmetrical on the positive side and the negative side. So we can analyze our graph and think about that and see that. Okay? Often you won't think about that or see that when you see the equation, but after, when you're like, oh, it's interesting that everything worked out to be the same and it's symmetrical on both sides, then maybe you go back to the algebra and say, what is it that made this happen? All right, question for practice on this one. Oh, and I do domain and range first before I get too excited about the homework. Domain. In this one, the easiest way to do it would be to say x can't equal plus or minus 5, but x could be everything else. And now the range is a little bit different in this one. Okay? The range, we've got everything from -infinity till -2, and then there's a gap, and then it starts again at 0. So if I was using interval notation, I could say it goes from -infinity to -2, not including that. And then it starts again at 0, includes 0, and goes to infinity. Because at -2, there's an asymptote. So that horizontal asymptote means that it's getting close to that value, but not including it. If you wrote this in the other notation, you would say y is less than -2, or y is bigger than or equal to 0. Questions for practice. There you go. It is the Statue of Liberty.